So this is a quick, too long didn't watch summary of this iDM02 drum machine repair. In summary, I wasn't able to fully repair it. I did get it working a little bit better. I do have some theories which may result in a working drum machine and a part 2 video, but I'm not sure how much more time I want to spend on it. I spent 4 hours so far. I've condensed that down to 1 hour, and you can see the whole repair process and how far I got in this video. I hope you like it.
Alright, what we have here is a Ion iDM02 stereo drum machine with trigger inputs. And this is a drum machine that's built on Alesis technology. It even says powered by Alesis on the back. And so the drum machine works. All these pads work. It'll play the built-in recorded songs, but the trigger inputs don't work. And there isn't a lot of information on these online, or this issue, but there is a post someplace that I found that indicated that it was a common problem and that there was a defect and it needed to be returned to Alesis or Ion or whoever is building this thing. So I'm going to pull this apart and see if I can't find a simple problem, a lifted ground or a bad chip or something, and repair this so that we don't have to go and splurge and spend another $40 to get a new one. Manufactured July 2007. Oh, there's 6 screws. Oh, the volume knob needed to come off. So there's a ribbon cable from the main control board off to the front panel. Added ground wire after the fact. That was a dip mounted socket. I have my lights off here, so I just bent the hell out of that. Okay, that could be corrected later. It's got piezos for detecting the velocity. I'd be interested to get in there to see if there's buttons. I bet there's buttons that detect the press, and then the piezos are detecting the velocity so that when you hit it, interesting idea. And it's a Bakelite circuit board, nice and cheap. Alright, so this has 1, 2, 3 screws holding it down. There's panel mount screws off, bolts. Comparing the screws to see if they're the same that are on the back that are on the inside, and they look to be the same. That way I could mix them without fear. So this was manufactured in 2007, which and it's because it's 2020. Lost my screw. Because it's 2020, that means the unit's 13 years old, which probably is a good indication that this battery is dead. I don't think that would affect the inputs. Okay. So this has 11 inputs on the back, and there is 1, 2, 3, 4, 5 wires going from the top board to the bottom board to trigger PCB. So I imagine that there's some other interesting electronics on the back. I see a lot of jumper wires, so this is probably a one-sided board. I wonder if just reseating this would help. I'm going to pad. Whoa! That kind of hurt. My camera took a dump. Hit me in the head. It's just a suction cup. Ow. And my screws went flying everywhere. That was fun. So I took out 6, 7, 8, 9. Took out 9 screws, and I found 3 of them. 1, 2, 3, 4, 5. Yeah, I'll just around here. That mount has been sitting there. The camera mount has been sitting there for about half an hour, and it came loose, and I could see it sucking loose now. And what's funny about that, I've had that mounted for 8 hours or longer, so I think it's just my surface is a little dirty. So I'm going to pick this whole thing up and clean the surface. Clean the surface of my pad. Try to set this back down. I should have an alarm or something. So far, I've bent some pins on a header connector, and I've dropped my camera on my head. So far, so good. And we're 14 minutes in. Oh, I think I found some more screws. Here's another one. Sure this is. Count through. 1, 2, 3, 4, 5, 6. We're only 6 screws now. And let's get a couple more. So one screws on the bottom of this board. So again, some screws. Okay, wow. Yep. A lot of fun stuff on the bottom of that board. Here's looks like to be the other side of that pad. Something looks like it got hot there. I'm going to take a look at it under the microscope. Interesting. There's a big gouge. I'll take a picture of it. And cracked trace. Ooh. Ooh. I think I found the problem. This circuit board's cracked. Wonder if it was always like this, or if it happened at the factory. It looks like someone was doing repairs. Aha! I found the culprit. That's copper. That's exposed FR4. And this green is the solder mask. So there's no green or copper here. This is a big ground plane area. The first one I saw was actually this one, which is a very similar kind of moon shape with copper
And my first thought when I saw it was maybe the manufacturer's cutting those traces intentionally. And that's kind of the first thing I saw first thing that I saw that was obvious. But as I looked closer, I could see that this pad was cracked. This pad is cracked right here, and that crack kind of seems to go through the board and through that trace and to this point here, and then it keeps going down, and it goes through all of these traces and through this ground plane and through this trace. And then it hit me when I saw this second moon shape over here that what's going on is that these are the mounting screws for mounting the drum machine to the rack, hitting the PC board because someone tried to screw it in super tight because it's kind of poorly mounts, and to get a tighter fit so that the drum machine doesn't kind of rotate around when it's being mounted. And so I'm gonna try to repair this. I think I could repair it. This trace probably doesn't need to be repaired because it's got solder on both sides of the fracture. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This probably doesn't need to be repaired. It's just some ground plane. 14 traces that need to be repaired. I noticed that crack, it goes up even higher. I could see it going all the way up here and even through that trace. So I said 14 traces before. So I think this takes it 15, 16, 17, 18, 19, 20, 21, 22, 23 traces. And then there's some crack on this ground plane, and it looks like it goes someplace. And so that might need to be repaired. And so I'm just going to start working on it right now. So this type of repair is actually not that hard. The biggest thing I'm worried about is did those when someone screwed into it, did that make a contact? Did the screw make a contact with the traces so that something got shorted and damaged the chip? Now the screws are they look to be like a black oxidized screw, so they may not be very conductive, so that may be a saving grace. So I think the thing to do here is just to fix this and see if we could get this to work. So these ones I'll probably just put a blob of solder on them. Just scrape off the solder mask, put blobs of solder, reestablish the connection. But those 4 traces that are down further, those are going to need some wires run. So I'm just scraping off the solder mask to expose the copper. Get through there. Don't know that I've actually ever done a repair like this before. I've done lots of repairs where I've had to scrape back solder mask and attach wires, but usually that's from my own designs where I made a mistake when on the PCB layout and I needed to correct it, so I would have to expose the copper. So I'm just using an X-Acto knife here to gently scrape. And you just kind of
press, like, you don't even really have to press down. It's more of a just scrape, apply enough pressure to take that green stuff off. Rotating the board so that I could keep my same scraping motion. So these are the ones I'm going to have to jumper. So I could see why in the post that I found they called this a defective board that needs to be factory repaired. Maybe what might have been good is to design this board so that there was holes in the circuit board, so those screws, if they got over tightened, would miss the circuit board altogether. Hindsight's 2020. Haha! I made the first hindsight's 2020 joke of 2020. The gutter is on. Just go in place. Yeah, so this looks like this plane is going under the microcontroller, or whatever this is. It says MIDI DC-703. MIDI-DC. So what I'm wondering is if maybe this is just some kind of MIDI controller and the 5-wire interface isn't MIDI, which would be kind of cool that if they did it that way. So I think I'm going to expose some of this and make sure that this plane is connected. This is also this goes here. It's connected to this. So I should probably reconnect this. I wonder if that works. There we go. Okay, I think all those traces are sufficiently exposed. I gotta find me some wire wrap wire. Okay, so now use a little PGA flux here. So I'm just picking up some flux with my X-Acto knife and moving around. I got lots of extra flux. I'm going to get all the copper pads exposed to flux. So the first thing I'm going to do is make sure that the tip will take solder. It's warm enough. It is. It's cold out here. Alright, so there. Just clean circle. There we go. Now this joint over here, touch and solder to it, but that is a separate joint. I don't want to zoom out a little bit, get some better light. So I don't want solder. This is all this right here is all part of this one joint. Okay, these are for traces. Solder. Use my thicker solder. Feel every tell. So these I have to do. So good. So what I'm doing right now is these are where I'm going to need to drop wires on, but while I have all this flux on here, I'm going to tin the traces up so that the wire wrap wire will stick to them. I want to clean all this flux off before I try to put those down because it'll be really hard to put down. This one here doesn't want to take, I think this has got a big joint here, and so the heat, I think, is... Oh, maybe I got it. The heat was keeping that big joint. I thought it was keeping it from making a bridge, but I think I got it. If not, I might have to drop a wire there. But yeah, I want to get these wires all tinned up. I have flux on here, so I want to clean the flux off. Right, with the wire. That's that. That's it. All side here. That's a bridge. Bridge removed. I don't remember if these were connected. I'm going to take some of the solder off so I could see if these were connected before or not. I do not remember. I definitely put a bunch of solder on there. Yeah, I think those were connected. All right. Most of these look like signal traces, so you just need a whisker to fix the repair. This one, however, looks like some kind of power trace. It's taken solder nicely across that bridge. Okay. Last one. I'm going to take that bead off. So I could get to my trace a little better. All right. That was good. Really hard to tell with all that flux on the board, like bridging the gap or not. That's not it. What's that? I'm looking away. Right. Good. Now the hard part, I got to clean all that BGA crap off, the BGA flux. So I'm just going to clean this off with some IPA or isopropyl alcohol. Q-tips. Cotton tip applicators. Thanks. Okay. I'm going to do another pass with a clean Q-tip. Okay. Just a paper towel with some water on it to sop up what's left. Okay. Q-tip. Okay. All right. It is impossible to look at the screen and see what's going on. I have to do it through the microscope. That joint may need a wire. I cannot get it to take. Lay the wire across the trace and solder it to both sides, and then cut it off. Takes a very steady hand. Alright. So the wire's still attached, but I got it soldered to both sides of the traces. And then I'm just going to X-Acto it off. Where's my solder? And I don't think I cut the trace, which is good, so I didn't make another crack. Okay. The next one looks good. It's kind of hard to see through the trinocular, but on the microscope itself, I can see this trace looks good, this trace looks good, this trace looks good, this one looks good, this one looks good. Let's see the solder. Yeah, it looks good, looks good, looks good, looks good, looks good. Yeah, it's connected. Okay, yeah, that was all one trace before. I was worried that it globbed it on. This looks now connected. This crack was going through here. Oh wait, this is not connected. So this trace from this pin go by R85 here goes through a cracked contact. So this looks like it needs to be repaired. This better work. Okay, yeah, that was easy. Nice big glob connecting everything together. So these traces here, there's 3 traces in a row that are just completely wiped off the board. So that I'm going to have to run wires for those. This one is not repaired. I'm probably going to have to run a wire for that. I might have taken off the trace. There's actually no trace here on the board. I probably took it off when I was trying to repair it. Just use the same wire wrap wire. Off the microscope, I'm tinning that wire. That's the trace right there. I'm going to try to connect to. Again, the wire wrap wire is still attached on the other side here. And I'm just going to, oops, and a big glob of solder, and I'm just going to cut it off. The copper there is just, that's the center of the wire wrap wire. I didn't expose any new copper. Would be nice to tin that over. I'm a little afraid to, I don't want to loosen it, but that's my lot in life. Yeah, so clean up that exposed copper. Okay, let's keep looking. I'm not so sure about. That one doesn't look connected. All these other ones are good. I'm going to try to reflow that one a little bit. I could always run a wire. Maybe I could just reflow it. Definitely connected now. Definitely connected now. Definitely connected now. All right, 3 more wires to go. So I've got to get those 3 traces. I've got to close the gap. I need to lay this wire down and close that trace gap. And the best way I've found to do this throughout the years is I'm going to pre-cut my wire to length and then do the soldering. It's real easy to rip the trace up if you try to cut it afterwards. And what I mean by hope it'll solder down is I'm going to expose I'm going to strip this wire with my soldering iron. Okay. Then I'm going to try to get it to solder to the circuit board. Just lean on this one. So, here's what it's going to do. Cut actually a little more off. There's a lot in there. Still a little bit. So now I'm just going to use some solder glob to take the insulation off and try to get it to stick to the trace that's there. Alright, so once it's 6, you don't want to touch it again with your hot end. Alright. 2 repaired. 1 more to go. I think I'm going to run this one all the way up to the pin, just because these are awfully close to each other. And runs up here. Wait, join these. This goes to the one. Put in little bends in the wires to kind of get them to follow the path I want it to follow. Let's put a little kink in it, and then I'm gonna move it to another area of the board to actually make the cut where I'm not worried about damaging a trace. A little bit of solder on the iron, and just kind of dip the end in the solder and just kind of go in a circle around, and it just kind of, the insulation on these wire wrap wires just melts right off. And then the other side, it'll so it kind of ripped a hole in the insulation where I was holding it with the tweezers, because it gets so hot that the wire just gets hot and it will melts through. Alright, stripping the wire off, the insulation off the other side. Just kind of melts right off. Alright. This side has the cleaner insulation removal. I'm using this on the chip side because it's super easy to develop bridges at the chip. Slight bridge. That's why God invented wick. Let's do this. Beautiful. I love wick. Okay, insulation removed. Arm wire, separate downward. Sorry. Insulation. Sorry. Oh yeah, there it is. No reason to do what I just did. Well, okay, I had a reason. Sometimes when you are manipulating around these wires, when you're soldering them, you kind of creating a crystalline structure in the solder. You get the other joint soldered down, but the initial joint is fatigued, and so it's nice to just tap it just to release that fatigue. Okay, everything's soldered. I'm going to give it another pass with some IPA and a Q-tip. Right. Okay. All right. Good enough for government work. Most of the resin's off. All right. That board, all the joints have been repaired. One last check for good measure. Alright. Looking good. Okay. Thought I saw a crack on the other side too. Can you believe it? The crack is definitely on the other side. Does it need to be repaired? This is just going to ground plane. and it wraps around, right? So I don't think it'll prevent it from functioning. It may make the circuit a little more noisy. But heck, this is a free drum machine. Okay. I think that's all that needs to be repaired in order to actually make this thing work, assuming the chips aren't blown from the short. So I am going to switch back over to my other camera now. Alright, I just finished the repairs here, and so I'm going to clean my workstation a little bit so I could reassemble this thing, mostly. These little black dots I found earlier, figured out what they were for. They were on the case covering the screw holes as maybe a kind of preventative measure to keep the screws from ramming into the circuit board. Didn't work so well. Washers would have worked better, or a shorter screw, either one. That's as tight as it can go. I don't even think a washer would help much. It's just I hate to say it, sucky design. But they're pretty inexpensive drums, especially the price I paid for them, which was nothing. Alright, so cleaning the workstation up here a little bit. Let's put some tools away. My soldering iron looks like it's still on. Shut it off. Can I get it out of the way? Put my knife away. My tweezers. Alright, so here's the repaired board. And this plugs in right here. And this guy plugs in like so. Put my solder away. It's this leftover wire, wrap wire. Okay, so this goes in this way. Move this pad out of the way a little bit. So this plugs in this way. It's a little dip header ribbon doohickey. I hate these things. And I guess when I saw it, I just assumed it was a like a 100 mil spacing header pin, because those things are they're a little bit more mechanically stable. So I tried to pull this out this way, but it needed to come up, and so I'm gonna actually kind of straighten these leads out a little bit. Luckily I didn't do too much damage to it. I would have hated to have to buy another one of these, especially since it's got this custom ground connection on it, which is, if I had to guess, it looks like an afterthought to address a RF problem, maybe even a noise problem, like a audio noise. But my guess is it's probably addressing an RF problem for FCC, because I don't know. Some music in the background here.
right. That one back together. That was actually glued in. Okay, so that is back together. And so let's see if the thing even still works. This is my, what do I got? And the middle one is the left output, and here's a pad. Plug a pad in, and AC. Where'd the AC go? Here's the AC. It's over here. Okay, comes on. So I didn't break it, and it still doesn't work. Aw, man, that was a ton of work. I'm gonna try a different pad. Oh, oh. I heard kind of got some solder on this. I heard it trigger. I heard it trigger. Oh, now it's not making any sound. Reset it. Interestingly enough, my kick is not working over here. Okay. I did read about a problem where this module would stop working and you had to cycle power. Now this pattern had a bass drum sound before. So it's not triggering at all. Okay. This is why you clean up. I've just found some solder wick on the PC board. Hopefully I didn't cause any damage.
power off. So I'm going to remove this guy. Turn the power back on. See if I get my bass drum back. Nope. Oh, I bet it's a bad connection over to here. This is not. Did I bend one of these pins? Nope, they all look good. Okay, so the pad's working. Maybe I just somehow changed the sound. Shut it off again. Try this one again. I thought, for a moment, I thought I heard the bass drum trigger on this. The bass drum would be over here. There's all kinds of crap on this. Be sure to clean off your desk so you don't blow up your circuit boards. Okay. It's working. That one worked. So those are triggered when I unplug them. So that one's working, the cymbal. I have the pedal. Oh yeah, hi-hat pedal's working. Bass drum pedal's working. I wonder if this pad's no good. Should we try this elsewhere? Nope.
Nope. This is the one that worked on the pad symbol. That's the symbol right there. Nope. Interesting. So the pedals may be a little different internally than the pads. So I got one pad working and one pedal. That's more than before. So hitting the plastic's louder than the sound from the module. All right. I don't know how much effort more I want to put into this. You could buy these modules used on eBay for $49, $45 even. And I think I probably spent 4 hours on this now. And I might take another pass at it on with the soldering iron one more time and see if I could get it going. But other than that, I think we've fully exhausted and examined the innards of the iDM02 ion drum machine. If nothing else, it's a cool SR16 drum machine from Alesis. I always wanted one of these. They were just too expensive, and now they're just ridiculously cheap, especially if you buy an iDM02. They're only $50 on eBay, where the SR16s are $150, and this is everything that an SR16 is, plus the trigger inputs, should they work if you didn't overscrew the clamp and break the board. So I hope you enjoyed this video, and I hope it makes it online.